There are 5 types of volcanoes: composite, shield, cinder cones, spatter cones, and complex volcanoes. Composite volcanoes, also called stratovolcanoes, are formed by alternating layers of lava and rock fragments. They are formed at subduction zones. These volcanoes often form impressive snow-capped peaks. When dormant, these volcanoes are often very quiet. They usually erupt in a very explosive way. This is caused by the viscous magma. When viscous magma rises to the surface, it usually clogs the crater pipe and the gas in the crater pipe gets locked up. Therefore, the resulting pressure will increase the chances of an explosive eruption. Shield volcanoes are huge in size. They are built up of many layers of running lava flows. Lava spills out of a central vent or a group of vents. A broad-shaped, gently sloping cone is formed. This is caused by the basaltic lava, which can't be piled up into steep mounds. These volcanoes can be produced by hotspots, which lie far away from the edges of tectonic plates. They also occur along the mid-oceanic ridge, where seafloor spreading is in progress, and along subduction-related volcanic arcs. Shield volcanic eruptions are categorized by lava fountaining that forms cinder cones and spatter cones at the vent.
Layers of the earth. Layers of the earth. Throw your hands up for the layers of the earth. Throw them up for what's below the surface. Throw your hands up and let's discuss the inner core, outer core, mantle and crust. Throw your hands up for the layers of the earth. Throw them up for what's below the surface. Throw your hands up and let's discuss the inner core, outer core, mantle and crust. Yeah. The layer we'll discuss first is the central inner core in the center of the earth, a solid ball buried below the dirt.
We believe it's primarily metallic iron.
You could never take a trip to the inner core, right? The heat will burn you up 9,000 Fahrenheit, 4,000 miles below the Earth's crust. 1 down, 3 to go, y'all. 1,800 miles from the tip top. The outer core is hard at work and it don't stop. It's busy spinning around the inner core. And listen, this steady movement causes Earth's magnetism. Ranging from 4 to 9,000 degrees, it contributes 1/5 of the heat flowing to you and me. It's liquid metal at the violently flow. So let it settle when you're ready, let me know. Just throw your hands up for the layers of the earth. Throw them up for what's below the surface. Throw your hands up and let's discuss the inner core, outer core, mantle and crust. Throw your hands up for the layers of the earth. Throw them up for what's below the surface. Throw your hands up and let's discuss the inner core, outer core, mantle and crust. Yeah. The mantle layer is the largest of the class, about half of our planet's mass. The mantle is composed of very hot, dense rocks that move and flow, always on the go. They never lock, never stop, and responsible for tectonic shift.
Please believe.
Earth's plates are adrift. It's pretty thick, y'all, and the heat is awesome. 1,600 at the top, 4,000 at the bottom. The continental crust surface is where we breathe. A lot of rock up to 25 miles deep. The oceanic crust is just next door. It's 3 to 5 miles thick below the ocean floor.
Earth's surface?
70% H2O.
Where you get all that water?
Salty sea flow. The rest is fresh water in the glaciers, ice caps, and snow. Let me see you throw your hands up for the layers of the earth. Throw them up for what's below the surface. Throw your hands up and let's discuss the inner core, outer core, mantle and crust. Throw your hands up for the layers of the earth. Throw them up for what's below the surface. Throw your hands up and let's discuss the inner core, outer core, mantle and crust.
In our world today, there exists 4 layers: the inner core, the outer core, the mantle, and the crust. The crust is made up of plate tectonics, on which our present-day continents are comprised of. These plates fit together as a jigsaw puzzle, as proved by the famous Alfred Wegener and his continental drift theory. These plates float atop the magma in the mantle, which are fueled by convection currents. There are 3 main types of plate boundaries: divergent, convergent, and transform. It is the movement in these plate boundaries that create the topography. At divergent plate boundaries, plates move apart and create new crust. As the creation of new crust adds to the boundary, a rift is formed. At convergent plate boundaries, two plates come together, destroying crust and recycling it back into the interior of the Earth, as one plate dives under another. These are known as subduction zones. Mountains and volcanoes are found where plates converge. There are three types of convergent boundaries. Oceanic continental convergence is when the oceanic plate dives underneath the continental plate and the overriding continental plate is lifted up, creating a mountain range. Oceanic convergence occurs when one oceanic plate slides underneath another, resulting in a deep oceanic trench. It also results in the formation of undersea volcanoes. The last type of convergent plate boundary is continental convergence. This is when two continental plates meet and neither one is subducted. Instead, the crust is either pushed upwards or sideways, creating mountain ranges. The last form of plate boundary is the transform fault boundaries. This is when two plates are sliding horizontally past one another. They produce zigzag plate margins and shallow earthquakes.
Give me what you got. I'm in the driving cars, crush up off the lot. I'm in the shutting stars down just so I can shop.
One of the most active volcanoes in the world is Taal Volcano, and it resides here in the Philippines. Taal Volcano is a stratovolcano, which was formed by the subduction of the Eurasian plate underneath the Philippine Mobile Belt. A team of the most qualified and intelligent volcanologists ventured to Taal to gather evidence that proves that Taal is indeed a volcano. The first thing we noticed was the caldera. In Taal, there is a large caldera, which proves there is volcanic activity on Mount Taal. Calderas are huge bowl-shaped craters, formed by collapses into the magma chamber or by explosive volcanic eruptions. Another piece of evidence we found is volcanic ash on the ground. Everywhere we walked, our feet sank deep into the gray volcanic ash. Volcanic ash starts off as volcanic rock. It is exploded from the vent in fragments that may be less than 2 millimeters in size. The ash we were walking on may have been solid or molten when first erupted. Whilst on our excursion, we also found volcanic bombs. These bombs are large, rounded lava fragments that are thrown out during an eruption. These fragments are usually modified in shape during their flight or upon impact to the ground. We found a large pileup of these bombs while observing the caldera.
Living here. At kano daw kayo katagal dito? Since birth? Basta dito lang ako ni anak eh. Yeah, she's born here.
Were you here when the volcano erupted?
She was 6 years old because that was 1977. She was born 1971.
Is the eruption good for livelihood?
Noon nga nakaraang 2010, pinaalis na yung mga tao dito. Ang ginawa niya, binigyan ng sangkapang bigas ni Vilma Santos. Dahil si Vilma Santos ang mayor, ang nagtukan dito sa buong Batangas. Mayor niya.
Hindi, gobernador pa sa ano?
Oo nga.
Is the volcanic ash good for crops and other vegetation?
I just asked that sure now.
What you say? Ask her. Okay, so is there a lot of tourism here?
Yeah, you know what it is. Black and yellow, black and yellow, black and yellow, black and yellow. Yeah, you know what it is. Black and yellow, black and yellow, black and yellow, black and yellow. Yeah, you know what it is.